Time travel. It's been a fascination of humans for decades, from Back to the Future to Avengers Endgame. But how much of what we see in movies is actually possible? And how much is pure imagination? Today, we're diving into the science behind time travel, what physics says, what's still theoretical, and why your DeLorean may never hit 88 miles per hour. Movies often show time travel as instantaneous. Hop in a car, press a button, and suddenly you're in 1985 or 3025. In Back to the Future, the DeLorean's flux capacitor makes it happen. In Avengers Endgame, the characters hop through time portals like it's a walk in the park. Of course, in real life, it's not quite that simple. Scientists have been exploring the theory, but no flux capacitor exists yet. Albert Einstein's theory of relativity gives us a clue. Time isn't fixed, it's relative. If you travel close to the speed of light, time for you slows down compared to someone on Earth. This is called time dilation. For example, astronauts on the International Space Station age just a tiny fraction slower than people on Earth. It's not noticeable for a few months, but theoretically, if you could travel at near light speeds for years, you could return to find decades have passed on Earth. And that's as close as modern physics allows to time travel into the future. Traveling to the past? That's trickier. Some theoretical solutions in physics suggest that wormholes, bridges connecting different points in spacetime, could allow backward time travel. But there are huge problems. First, wormholes are purely hypothetical and would require exotic matter to stabilize. Second, changing the past introduces paradoxes, the classic grandfather paradox, where you could prevent your own existence. Most scientists agree that backward time travel is probably impossible. Movies and TV love to play with the idea because it sparks imagination and storytelling possibilities. From fixed timelines to multiverse theories, each story chooses its own rules. That's why time travel in fiction is less about physics and more about exploring choices, consequences, and creativity. And honestly, that's part of the fun. Time travel lets writers bend reality in ways our brains can't resist. So, can we really travel through time? Forward, yes, in tiny ways through time dilation. Backward, probably not, at least not without breaking our understanding of physics. But through imagination, stories, and movies, time travel exists for anyone willing to dream. Next time you watch a time travel movie, remember, the science behind it may be theoretical, but the fun, the adventure of exploring what if, is very real.